Hai, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we will talk about experiment on displacement of halogen from its halide solution. So if you have problems on the concept, you can watch my previous video. In this video, we will focus more on the experiment part of the concept. Okay, so let's look at the experiment first. Now let's look at the lab activity 1D. So this is in page 20 in your textbook. Okay, the aim of the experiment is to investigate the redox reaction in the displacement of halogen from its halide solution. I already explained to you the term halogen and halide in my previous video. For this experiment, we have two parts. The first part is to see the color of the halogen in aqueous solution and also organic solvent. So when you add the aqueous solution into organic solvent, which is 1,1,1-trichloroethane, you will see that the color of 1,1,1-trichloroethane will be different compared to the aqueous solution, especially for iodine. So this table will explain to you the color in each solvent. So I have the color in the pure form, the aqueous solution, and in 1,1,1-trichloroethane. And note that we are not using fluorine because fluorine is a very reactive halogen. So we are not using it in the lab. So we are using chlorine, bromine and iodine. For chlorine, it exists as greenish yellow, usually exists as gas at room temperature. Bromine can exist as liquid or gas. So bromine pure form is a reddish brown color. For iodine, it usually exists as solid. Okay, because the melting point is higher compared to bromine and chlorine. So the color of iodine is purple black. Okay, but iodine can undergo sublimation where it will change from solid to gas when we heat the solid iodine. So this is the actual color of chlorine, bromine and iodine. So in the aqueous solution, the color of chlorine is pale yellow. Bromine is brown or yellowish brown or yellow, depend on the concentration that we use. Iodine will have a similar color to bromine, which is brown, yellowish brown or yellow. Also depends on the concentration. So let's look at the color of this halogen in aqueous solution. So this is the first row, the color for this halogen in water or in aqueous solution. So the color of chlorine is pale yellow or almost colorless. Okay, for bromine it is brownish yellow. For iodine it's also yellow or sometimes if the concentration is high you can get the brown color. For the color of chlorine, bromine and iodine in 1,1,1-trichloroethane, chlorine will be pale yellow or colorless. Bromine will be brown, yellowish brown or yellow, so same as in the aqueous solution. But iodine will exist in purple color in 1,1,1-trichloroethane. So if we look at the diagram here, so you'll see that the color of iodine is actually quite obvious. Okay, the difference in the color of chlorine, bromine and iodine is obvious, while chlorine is pale yellow, bromine brown, yellowish brown, but for iodine you'll get the purple color. In this experiment you will not get this one layer of solution or liquid, but you will have two layers of solution and liquid because you are adding the chlorine water, bromine water and iodine water in the 1,1,1-trichloroethane. So if you look at your textbook, they will say that you have these two layers of solution and liquid. So in this video, I will paste to you the video of how you can see the difference in the two liquid and solution. If you look at the video that I show you, you will see that in the test tube, there is two parts of the solution. The bottom part is actually the organic solvent. The upper part of the test tube is the aqueous solution. So when you look at the test tube, so note that the bottom part of the test tube is for the organic solvent. This is because 111 trichloroethane is more dense than water, so it becomes at the bottom part of the test tube. If you see the experiment showing in your textbook, so if you look at your textbook, there are QR code, okay, that you can see the experiment for the displacement of halogen. You will see that the color of purple is on the upper side of the test tube, not the bottom side of the test tube. This is because they are using cyclohexane, which is less dense than water, so it will be on the surface on the upper side of the test tube. Okay, so please note that this is the difference between cyclohexane and 111 trichloroethane. Okay, now let's look at the second part of the experiment. So this is the displacement reaction of a halogen from its halide solution. So this is the solution that we use: potassium chloride, potassium bromide, and potassium iodide. And the reaction is between bromine water, iodine solution, and also chlorine water. So let me simplify this table for you. So now we are using KCl that react with bromine and also iodine. Then we have the potassium bromide that react with chlorine and also iodine. The last one is potassium iodide that we try to react with chlorine and bromine. Okay, from the previous explanation, the concept, we have to determine which reaction will produce new product, which reaction will not produce new product. So this is based on the reactivity. Okay, for the first experiment, potassium chloride react with bromine, so bromine is less reactive, so bromine will not be able to displace chlorine from potassium chloride, so this reaction is not going to happen. Okay, iodine also less reactive compared to chlorine, so this reaction will also not happen. Okay, the third reaction, potassium bromide and chlorine, so chlorine is more reactive than bromine, so chlorine will be able to displace bromine from potassium bromide solution, so this reaction will have a new product. For iodine, iodine is less reactive, so this reaction will not happen. Okay, potassium iodide, chlorine is more reactive than iodine, so this reaction will have new product. Bromine, okay, sorry, tertinggal kat situ. So bromine is more reactive than iodine, so bromine will also able to displace iodine from its halide solution from potassium iodide. Okay, now when we do this experiment, you will see two layers of solution and liquid. So what you have to know is, okay, the bottom part of this test tube, so this two is actually the halogen is in 111 trichloroethane. So this is the organic solvent where the halogen that we don't say dissolve, kita kata halogen that is in 111 trichloroethane, it mixed with 111 trichloroethane, will produce a certain color. For example, purple is for iodine, okay, brown, yellowish is for bromine. For the upper part of the test tube. So this is the halogen in the aqueous solution. So if you look at the color of the upper part of the test tube, so you'll note that the color is for the halogen in aqueous solution, means it is for potassium iodide, potassium bromide, or potassium chloride. So let's see the first experiment, okay, where we react bromine with potassium chloride. Okay, so bromine is below chlorine. So bromine is less reactive than chlorine. So bromine will not be able to displace chlorine from its halide solution. So this reaction will never happen. Okay, so bromine is less reactive. So if bromine is less reactive than chlorine, so the reaction will not happen. So your product will still be bromine and also potassium chloride. Maknanya produk tu dia tak berubah. Dia sama macam the reactant. So if you look at the test tube here, the bottom part of the test tube is actually referring to the color of bromine in 1,1,1 trichloroethane. That's why you have the brown yellowish color there. So the brown yellowish color is bromine in 1,1,1 trichloroethane, and the upper part of the test tube is actually the color for potassium chloride. So potassium chloride in aqueous solution is either colorless or pale yellow. So you will get a pale yellow solution and it is almost colorless. Okay, because there is no reaction, so the color of the two liquid and solution in the test tube will be same as when we react the two reactant. Okay, so this is the first part. So no reaction between bromine and potassium chloride. So if we react iodine and potassium chloride, so there will also be no reaction. So in the test tube, so what you should see is that, okay, if you have the two separation of liquid and aqueous solution there, so the bottom part will be purple. Okay, yang bawah ni dia akan jadi color purple. Why? Because, okay, the iodine will dissolve in 1,1,1 trichloroethane. The potassium chloride will still exist as the aqueous solution. So the reaction is not going to happen. Okay, so this is for the first two reactions. So both reaction actually don't produce new product. Okay, so no reaction lah actually. So let's look at the third reaction where we react potassium bromide and chlorine water. So this is the reaction between KBr and Cl2. So chlorine and bromine, chlorine is more reactive than bromine. So chlorine will be able to displace bromine from its halide solution. So the product form will be potassium chloride and bromine water. So bromine will be displaced in this reaction. So let me balance the chemical equation. So you need 2 KCl and 2 KBr. Okay, in this reaction, as you can see, the observation for this reaction is for the product. So this is the aqueous solution, okay, potassium chloride, and this is halogen in 1,1,1 trichloroethane. So this is the halogen. So when we see the observation for this reaction, so you will see that the bottom part of the test tube, is actually the color for bromine in 1,1,1 trichloroethane. So it's yellowish brown. Okay, the upper part for the test tube is actually for potassium chloride. See, so it is almost colorless or pale yellow in color. So this reaction produce new product. Okay, and this reaction is also a redox reaction. Okay, how do we explain this redox reaction? So I already explained in my previous video. So I just simplify the chemical equation. So the reaction is between potassium bromide and chlorine. So you need 2 potassium bromide, produce potassium chloride and bromine in molecule. So in this reaction, so as you can see, the bromide ion change into bromine molecule. So if we look at the half equation, so I can write that 2Br minus release electron to form bromine molecule and it release 2 electron. So if you have loss of electron, again, okay, this is the oxidation reaction. For oxidation reaction, if we want to explain in terms of change in oxidation number, so you can say that the oxidation number change from -1 to 0. So oxidation number increase from -1 to 0. And potassium bromide is the reducing agent. So in this reaction, chlorine accept electron to form chloride ion. So the half equation will be Cl2 plus, okay, accept electron to produce 2 chloride ion. So this reaction gain electron. So this is reduction reaction. So again, we can also explain it in terms of change in oxidation number. So the oxidation number change from 0 to -1. So you have reduction reaction, oxidation number decrease from 0 to -1. Okay, so chlorine is the oxidizing agent. Okay, so this is the first reaction. Okay, you can write down the half equation. So this is the half equation. 2 bromide ion release 2 electron to form bromine molecule. Chlorine accept 2 electron to form 2 chloride ion. So let's look at the next reaction. Okay, this is the reaction between potassium iodide and chlorine water. So in this reaction, we are reacting potassium iodide and chlorine. So again, chlorine is more reactive than iodine. So chlorine will be able to displace iodine from its halide solution. So the product is potassium chloride and iodine as in molecule. So you need 2 potassium iodide and 2 potassium chloride. So in this reaction, if you look at the picture there, so the bottom part of the test tube is actually the color of iodine in 1,1,1 trichloroethane, because the halogen is a covalent compound. It will dissolve in another covalent compound. So the purple color here is actually for iodine in 1,1,1 trichloroethane. So that's why you can see the purple color formed. Okay, the purple color is actually for iodine in 1,1,1 trichloroethane. And the upper side of the test tube is actually the color for potassium chloride. So potassium chloride is the aqueous solution. The color is almost colorless or pale yellow. So So in this reaction, same as the previous reaction, is a redox reaction. The half equation is almost the same. How you explain is also the same. Okay, it's just that in this video I am focusing on the observation. So how do you see the observation for the product form? Okay, so the purple color again. Okay, the purple color here is actually the color for iodine in 1,1,1 trichloroethane. So iodine in 1,1,1 trichloroethane produce purple color. It will show that iodine is already displaced by chlorine in this reaction. Okay, now let's look at the last experiment where we react potassium iodide with bromine water. Okay, it will produce potassium bromide and the iodine molecule. So bromine is more reactive. So bromine will be able to displace iodine from its halide solution. So it will produce iodine. Okay, so iodine being displaced. Okay, so you need 2 potassium iodide and 2 potassium bromide. In this reaction, as you can see, the bottom part of the test tube is purple color. So this is actually the color for the iodine in 1,1,1 trichloroethane. So that's why you see the purple color, because iodine is already displaced by bromine molecule. And the upper part of the test tube, okay, this is the color for potassium bromide. So potassium bromide in aqueous solution, the color is brownish yellow, or brown, depends on the concentration. So in this case, the color is yellowish brown. So as you can see here, okay, when we talk about the observation is what we see during the reaction. The inference is the fact behind the observation. So let me explain for this reaction. Okay, as you can see here, so you can see that the purple color in 1,1,1 trichloroethane. Okay, so this is the observation. The inference will be the iodide ion release electron to form iodine molecule. So this is observation, and the second row is the inference. So the iodine ion already released its electron to form iodine molecule. Okay, for potassium bromide, okay, the bromine will accept the electron to form potassium bromide solution, okay, to form the bromide ion. So bromine accept electron, iodine release electron. So this is a redox reaction. So basically these two reaction using chlorine and bromine. So chlorine and bromine is more reactive than iodine. So both reaction will produce a new product. Okay, so I want you to try out the exercise that I paste in the description area. So you can try to write down the half equation, the ionic equation, and determine which one is the oxidizing agent, the reducing agent, the reactant that oxidize, and also the reactant that reduce in this reaction. Okay, thank you for watching my video. So if you have any problem, you can tell me in the comment area. Don't forget to subscribe and like the video if you find that my video is helping you. And another thing, that I tried to do this experiment in my lab, but the problem is I didn't get the theoretical color of the halogen in 1,1,1 trichloroethane. Maybe the chemicals that I have in the lab is already oxidize ke apa ke, saya tak tahu, tapi mungkin dah expired, so I didn't get the color, that's why I'm using the picture there. Okay, so you can Google up the video on this reaction, but note that if you have the purple color on the upper side of the test tube, means that the organic solvent that they are using is less dense than water. Okay, so the upper part can be the organic solvent if the organic solvent is less dense than water. Okay, if the organic solvent is more dense than water, density ketumpatan. Okay, jadi kalau dia lebih tumpat, dia akan duduk di bawah. Kalau dia kurang tumpat, dia duduk di atas. Jadi ada gambar dekat internet yang kamu akan jumpa purple color tu atas. Kadang-kadang purple color tu dekat bawah. So kenapa? Sebab organic solvent yang dia gunakan tu berbeza. Okay, so nanti next video saya akan try untuk explain standard electrode potential. Tapi before that, saya nak explain juga tentang ada perubahan dalam buku teks you all on the transfer of electron at a distance. It's just experiment je lah. Okay, so thank you for watching.